I'm super excited to be here and speaking at JSConf. My name is Mariko, and that's my Twitter handle. I should be automatically tweeting this slide, link to this slide, so if you are in the back and you want to see that, you can find it there. I will be joining a company called Scripto next week, which I am super excited about that. But today, I am not going to talk about software engineering, I'm going to talk about knitting. And just in case you're wondering you were at the wrong conference, I will assure you that I will have enough math and code example for you to be interested. Just for the guideline, I have a visualization down on the slide. So the blue dots are indication that the slide has some kind of math reference, computer science reference. Radius of the circle is how many scoops of ice cream I served myself after I figured that out. The yellow dots are some random GIF animation because why not? So I like knitting. I've been doing knitting for quite a while. I think my first time I doing it was 7 years old. That's something I've always done, once a year. Come winter, I knit a scarf or mitten or something very simple and nothing crazy like having an Etsy store or anything. So here's a few of my projects that I've done in the recent years. One winter, I think 3 years ago, was very special winter for me because I learned to JavaScript while I was also working on this green scarf project. And I started to notice that really interesting parallel between computer programming and the process of knitting. So for example, when you get started, if you never knit something, knitting might look like this. 7-year-old me was I'm never going to be able to figure out this thing that mom and grandma is doing. So intimidating. My experience with programming for the first time was just installing npm install on the terminal was so confusing. I was words flying around and is my laptop being hacked and what's going on? But we all know that once you've done it once and know what it exactly is doing, it's not so scary at all. The other thing, that computer programming is very binary that we think. Knitting is very binary. The atomic unit, the smallest unit that you can do is 2 stitches, which is knit stitch and purl stitch. Knit stitch is the stitch that you pull the yarn from the back of the loop, and purl stitch is the yarn, you push the yarn from in front of the loop. And those 2 stitches create 2 distinct faces of fabric, and the combination of those 2, much like we say programming is a ones and zeros, creates a pattern in the fabric. So the green side of the fabric, which is 2x2 ribbing, which is commonly used for the cuff of your sweater or the neckline of your sweater, is basically 2 knit stitch, 2 purl stitch alternating each other, and then just going row by row. The other side of the pattern is the one I took from my sweater, which was a little more intricate, making kind of diagonal line and looks intimidating. But if you look closely, it is just knit and purl stitch, just one stitch by one stitch shifting to the left to create a diagonal line. Knitters have a GitHub, actually. It's called Library. And this is somewhere people log in. You put your patterns. You could sell your patterns. You can start somebody's projects and log, share the photos. And it is really a central repository of knowledge that you do with knitting. And in speaking of a central repository, code for knitting, the knitting pattern looks like this. And I thought this was totally look like code because there's some letters that's kind of repeating and maybe kind of a variable that's accessing the same information again and again. And there's more explicit loop indication knit until 2 stitches remaining or repeat row 1 to 4 for 10 times. This brings me to, I could pseudo knit in JavaScript. So I took this code, which was a scarf pattern, very simple scarf pattern, put it into 30 lines of JavaScript to visualize what this would look like virtually. And this is what I came out. It turned out it's only using a knit stitch. It's not a purl stitch, so it's okay. And it's knit scarf, so making triangle shape, which is all right, I can understand that. So I actually knit that pattern myself, and I have it here. But turns out it didn't quite become triangle. Instead, it became on like an arc. So in my code, those yellow stripes should be straight flat line, but then it became arc. And I was like, this is only 39 of JavaScript, and I like JavaScript professionally. Like, where's my bug? Like, I can't figure that out. So I have it here where my 4 stitches started here, like 2 inches or so, and then I knit it down. And if I force the fabric to see it, you could say that this was like straight line, but in fact, it ended up being an arc of a scarf. So why? I did a little bit of research and found out that what I was discovering was something called hyperbolic geometry in math. And I was like, okay, in knitting, we call it ruffles. So I did furthermore research, and there's 3 kinds of geometry to describe, and they both use one perfectly straight line. The one we are familiar is Euclidean space, which you have a baseline, and then parallel to that, you have another line that will never meet the baseline again. So it's like very 2D. The other one is spherical space, where the straight lines are on the sphere. So however you place it, it will always meet each other. And the third one is a hyperbolic space, which there is a baseline, and the straight line, the infinite number of straight line can be drawn. And turns out this hyperbolic geometry is a hard problem to solve in computer graphics because it's hard to model. Researchers at Cornell actually created a physical model of hyperbolic geometry in knitted fabric, in her case created in the crochet. And here's her paper about how she created the hyperbolic plane. So when I discovered this, I just stumbled upon problem making ruffles. But when I discovered this is actual math problem behind my ruffle, I was like, this is great. I want to do more of this. I want to discover more about pattern making, and I want to do this. The problem was that knitting is a very slow process. This scarf itself took maybe 5 days of solid work, so 8 hours a day. And if you think about software engineer salary, this is a very expensive piece of scarf. So I did furthermore research about how can I test out my patterns, and stumbled upon this thing called knitting machine, which I have never knew that this existed, but apparently it existed for home use, available to your house since 1890. And this is the ad from that era. And furthermore interesting as a native Japanese was that knitting machine was very popular piece of things to own in the household in 70s and 80s, Japan. And people were offering local classes, people owned the knitting machine like you own a sewing machine. I found one TV commercial on YouTube about this knitting machine from 1979. If you can get the audio. All right. So I am as confused as you are to see this TV commercial for one different reason. The song that was on the background, the lyrics said that creating a special original pattern knitwear is like sending a secret love letters to your loved one. And I thought that was kind of creepy, but apparently things to do in 70s. I lived in New York City when I discovered this, so I couldn't really go down to local classes, so I don't even know if that's offered in Tokyo now. But I, made a short trip to eBay, spent a couple of $100 to buy this machine. And I got it, I set it up, and I was like, okay, I'm going to set this up and rock and roll. Create all of the patterns, and I'm going to be awesome and create sweaters. Turns out, operating the machine, even before going into creating a pattern, was a lot of work. The machine was made in the 80s. It was sitting in somebody's closet for a long time. It was missing the manuals. So I ended up next 2 months just researching all kinds of stuff on Japanese blog posts about machine knitting, possibly watch every single YouTube video about machine knitting that's posted. Many of them are Japanese. Occasional trip to a free preview version of Google Books because I couldn't just go down to a Japanese bookstore down the street from my parents' house and pick up the book. I never thank myself enough to be able to speak Japanese because all of the stuff, great stuff, was available in Japanese. And I just get so angry when software only offers a documentation in English because certain things I could not understand. But in knitting, at least I got my turn to just do things in Japanese. On top of figuring out how to operate the machine, I actually needed to fix the machine. So I figured out how to operate this machine, moving carriage back and forth, but it wasn't knitting quite right, and something was missing. And basically, I flipped the carriage, examining what exactly it's supposed to do and what each path is doing. And after looking at maybe 4 hours of mechanics of things, I found out that the one piece of thing was stuck in there. And just a jiggle, it worked perfectly. And so finally, I got to knit a fabric out of the machine, and I was like, this is great. One thing about this machine is known for is something called Jacquard knit, or Fair Isle knit, or pattern knit, if you're familiar with those terms. And if you've studied textile before, the word Jacquard directly comes from Jacquard loom, which is a different type of machine that creates a patterned fabric and use a punch card as an input to the input of the data. And this punch card system, the punch card loom, became base of the modern computer, which is, I thought this was great discovery. When I did the research and learned about it, I was so excited. So the machine is based on that, and you see on the 70s ad, the machine actually had a punch card feeder, so you create your own punch card and then feed it into punch card feeder, and then that will translate the pattern for you. My machine is coming from the 80s, so it is an electro-knit. It's actually the name of the model. It's called electro-knit, and what does that mean is that it no longer has a feeder for punch card, but it has a motherboard and chip and a magnetic strip. Use electromagnetic to push and pull the needles automatically. It's a lot like dot matrix printing if you are familiar with dot matrix printer. One pixel becomes one stitch. So in this machine's case, I feed it a yellow and blue yarns. The needle that's pushed forward is grabbing a contrasting color, which is blue, and then the needle that was left on the behind is grabbing a base color, which is yellow, and that's how they create a pattern. So that means I can create some kind of graphic, anything, in this case JSConf logo, and then put it into a knitted fabric. And I was like, I found out how to operate this machine, I fixed this machine, this shouldn't be a problem. I'm gonna do this. Turns out it was not that easy. Not even so there was so many things that you needed to figure out, which is indicated in that blue dots, even before you actually put the data into the machine. So first question was how do I even make bitmap image? Because if you're using Photoshop, you just load the colored photo in, select the grayscale, and then select the bitmap method, and then it just automatically feed it out the bitmap for you. But I needed to do this in code, so how do I programmatically do that? Well, let's start with just learning about image and loading the image. I used a library called Graphics Magic and then npm package gm, which wraps that library. I actually started by using Phantom.js, creating a canvas in Phantom and loading the image and using the Canvas API to extract all of the data, which worked fine, but it was very slow, and GM was suggested to me as a faster alternative, and it worked perfectly. So when you load a file into GM as a text file, this is what you get: XY coordinates of the pixel, RGB value of the color, and then also the hex value for that color. So all you do is a handy-dandy regexing and create an array of arrays for each pixel. So now I have RGB color for each pixel. Let's get on it and make it grayscale. But how do I grayscale? And I spent like 2 hours just looking at this single Wikipedia page about grayscaling, and it has all the math formula. And I think I figured that out, and the engineer from Adobe confirmed that that's okay. So I'm more confident about my explanation here. You have RGB value for each color, in this case pink and green there. You find a highest value in each color. In the pink's case, red is the highest value. Green case, green is the highest value. You repeat that number 3 times over the RGB value again, and then you get a grayscale, the color. So now you load the image in GM, you get all of the color, and you 3-color RGB value array, you just find the max value out of that array, and then you have an array of just a max value, and you can use that to create a grayscaled image. So I was like, this is black and white photography, so I can just load it in because it's black and white. But the grayscale image is actually black and white and many shades of gray in between. And my machine only has 2 colors, so it has to be just 2 colors, nothing in the shades of gray. So my first approach was to split it in half. Anything that's closer to white side gets white, and anything closer to black side gets black, and turns out like this. Like something like what came out of fax machine. I wasn't really happy with that. So I was like, this is my favorite game when I grew up, when I was growing up. And this only used black and white, and it operated beautifully in my tiny Apple computer. So I literally Googled Cosmic Osmo graphics, and I encountered that I needed to do something called dithering, which at that time I read the Wikipedia article saying intentionally applied form of noise, and I'm like, I don't really understand, but okay. GM has a built-in methods for it. So I did that. It turns out better than my method, but still somewhere around the area is missing a definition, and I wasn't quite happy with it. I did further more research and discovered that the thing that I needed to do was something called ordered dithering or half-tone screening, which is used for newspapers to translate that picture into a newspaper, which is just 1 color of ink. So you have a base image, which you extracted the value for the grayscale, and then you have this noise matrix part. You laid it over. You compare the overlapping pixels, and if the base image has lower value than your noise matrix, then it gets 0. If it's over, then it gets 1, and that's how you make it into 2-color image. And of course, if it's 1 and 2, you can put it into 1s and 0s matrix. Here's a few examples of that noise matrix, and a lot of people explore their own matrix to create a better dithered image. I ended up using Bayer because I like the output most. So now I loaded the JSConf logo and outputted it as a 1s and 0 pictures. And if I replace the 0 with no value and then 1 with asterisk, you can see something like this, and starting to look like something on the knitted fabric. So I was like, okay, great, I got files. Let's just put it into the machine and just knit. So let's make knitted pattern files. The file format for this is something called .dat, which I think stands for digital audio tape. I have no idea. If you open it in Sublime, it's a bunch of zeros. And I was like, okay, great. It's binary file. Just put my 1s and 0 matrix, replace it, and then go it in. But I found out that if the pattern is in there, it's actually hex. So I was like, there's something needs to be done in between my ones and zero matrix into this file. What do? There's one guy, Steve Conklin, who is leading the same kind of project in Python. So I studied his code and discovered this line. And at the time, I was a newbie Python developer, so I was learning Python. And I was like, what's this? Like, I just went through like Python tutorial, nothing mentioned about Bitwise Operator. Like, how could I not ever heard of this? I just went through training. And I felt like this. Like, I also found out that the Bitwise Operator exists in JavaScript, and I read MD an article, and still couldn't really get what it is. So what I concluded after like 2 days of like, throwing balls against walls, was that this is like magic. And this is my interpretation of what Bitwise Operator and bit shifting is. So I'm going to give you two examples, which two operations that I use for this machine. One is a bitwise left shift. Left shift is a guy or fella who pushes you to the left. And he's a magician because it's Bitwise Operator, so he has a magic hat. So let's do this. The A is a decimal 1, the value of 1, and let's bit shift 4 to the left. So the representation of decimal 1 is that, and this left shift guy comes in, push you 4 times to the left, and because he is a magician, he makes it to 16. Like, how could that happen? Okay. And the bitwise OR operator, the same thing. This person favors 1 over 0, and he's also a magician. So let's do bitwise OR between decimal 1 and 5. Representation of decimal 1 and 5 is that. First, compares 1s and 1. There's only 1, so he chooses 1. There's 0 and 0. So there's no 1, so okay, 0. And next one is 1s and 0, so okay, 1. And because it's magic, it stayed as 5, even though you just did something, but it stays as 5. So I needed to do whole bit shifting, and if you're interested, I'm happy to share the code. But my 1s and 0 matrix shifted into one set of decimal value array, shifted again, became one number, and then turned that decimal number to hex, and I can finally put it into my knitting machine. So now I have file prepared. I processed the image, file prepared, and put it into the machine, and now I want to demo the machine. Okay, so I just turned it in. I preloaded file this morning. I use USB to serial port cable, which the tutorial of how to make is available online. And just select the 9. You might not be able to see it, but well, I'm selecting a custom pattern that I created. It says 1 times the stitch of 90. Okay, start. I change the setting, make sure everything is okay. And now something interesting starts to happen. See, these needles are pushed forward. This means that this carriage used the magnetics to pull those needles, and then now these needles that's pushed forward is picking up this blue yarn. And all right, now that the pattern is done, I can just discharge this, take this out. Actually, just leave it there. You may not be able to see it from the front, but it actually printed out JSConf 2015 logo. And after that, I'll finish this scarf, and I can show it to you in person if you're interested. Woo! Thank you. Oh, how kind, thank you. So going into this project, I had no idea what I was doing. I just wanted to do knitting, and I discovered that knitting and JavaScript is kind of related. That turned into finding out about this machine, and I wanted to do this. I had no reservation about trying to sound smart. This wasn't my job. So whenever I go into problem, I just tweet out or send the emails about it, and so many people just jump right in, sending me code samples and giving me encouragement and all of that. So I just want to give a shout out. Thank you. And most of the code will be available on Electronet repo, which is right now is empty, but I promise I will put it up. And a subset from that project, the part I was doing the color math, I was super interested in it, and I added more feature about translation between color spaces and created a small library for you to explore the color on the command line, and that's available on the color mixer repo or NPM module. So thank you.